profession is a fundamental questioning of, is it necessary, right? We are, the way that you guys have projected to build a building that will be here 100 years from now is so atypical in terms of the way that we build typical buildings in the United States, that it is almost an anomaly that you would have to go through this level of sort of justification.
It's not justification so much as what
analysis.
is the quantity in comparison to what, I mean, you know, what are we comparing?
If we can encourage more designers who are building buildings that are scheduled to last 20 years to ask that question of, is a material that can last 400 years the right thing to build my 20-year structure out of? Right, we're building strip malls out of concrete, can last 400 years, and out of steel that can last 400 years, that have enormous embodied energy footprints, and embodied carbon footprints. And no one's ever coming back and challenging those, saying, that building's only not gonna be here 25 years from now. Maybe a different material is the right material to use.
Yeah.
I see you have more typical buildings. Can you do a comparison of the final slide that you showed? Can you give a comparison to a more typical building in terms of the structure emissions and the operational emissions?
Just some of the pieces that were built into parts that we were looking at. For example, we made an assumption of about 6.5 pounds of steel per square foot of floor for a typical one-story steel building. That's pretty standard for a building that's going up for a one-story in a mall, any of the box buildings, right? That was sort of embedded inside, but that could come out here. So the structural, I mean, we can add more to that. Layla's only just getting ready to move into her dissertation phase. She's got time to really sort of add some depth to it. But I mean, that's one kind of thing, and that's why I asked her to really start to take a look at that, because you know, one-story steel is a choice that's out there to be made, and it's often the choice that's made for what's going up, or even one-story steel joists instead of structural steel that happens throughout there. So there's a lot of choices that are made, but the other issue about how long we amortize our buildings, which was sort of outside of this scope, is a huge difference that anyone who's actually out there working faces. I've been involved in projects that are driven by developers that are looking at 5-year paybacks. And this is a project with a client that's looking at a 100-year life of the foundation and the building. Those lead to two very different choices that are being made in the design process. And you know, trying to get people to rethink decisions for the life of the building, I think, is one huge area where things can happen.
I know you guys went basically just in the bones, the shell of this. Did you guys look into more like the materials that went into it? For example, I happened to read it, and I still have yet to get enough time to get into it, a white paper that's like 80 pages long. But it happened to be from a structural engineering point of view of all this stuff talked about, and then it started getting into some architectural materials comparing like OSB versus plywood, and showing the huge differences in the carbon relation to that.
There are SIP panels in this building, and hopefully that would become a part of the final analysis, both the styrofoam and the plywood. The local wood that was used for flooring that was harvested on site was transported up to a mill and was both processed and kiln dried. The outside siding was not, so the level of detail going into some of those other issues could go further into this. And I think that's really an overall goal, because even though much of this is one-off to a certain extent, if there is a material that sometimes architects have the chance to work with, it can be working with harvesting lumber locally. It can be working with lumber that is harvested as a part of urban forester, harvesting the material. I know that I've worked on projects that have involved furniture that's made from wood that's been harvested by trees that have been trimmed by the City of Milwaukee forester. So the notion that locally harvested wood is really an anomaly, I think, is maybe not so much as we might think. mean, it is an anomaly to sort of go through it to this extent, but I think that more and more there are people that are looking around at local sourcing. I mean, the local sourcing of stone is available anywhere where there's quarries, and there's a lot of areas that stone can be used. You can drop stone into foundation walls with cement to replace a good volume of the cement and still get a wall that has good compression capacity, as long as you're doing your drainage properly near it, so you don't have to have it totally reinforced. You don't have to use the same volume of cement in order to get a reasonable foundation.
The other quick question I have is going back to the fly ash, because I have no knowledge, and I didn't even know about the mercury in it. Is that mercury, unlike bulbs where if they break, the mercury goes, is the mercury in that fly ash innate, so therefore, yes, it's there, but it really is not harmful at all? Because I know there are those cases of materials like that where they're harmful materials, but as long as they're in a certain state, they're not harmful.
The place I'm worried about it actually is in pavements for freeways. Because if you look at the way when they go through and redo a freeway, they chop up the concrete on site to create aggregate to go back and recycle it into the freeway. So if you have used fly ash cement on a freeway, you can start to talk about pounds of mercury per mile. I mean, it gets to a different level when you're looking at a 1 mile strip of 2 or 3 lanes in either direction. And when you are chewing up the freeway and reintroducing it, you have a period where that material is subject to the possibility of rainfall and going into the ground. So I think I would be more concerned about that than the much smaller recycling of concrete where it's embedded in the building.
So basically then my thought has always been that if fly ash is used for the concrete in the building, it's not going to leak into the ground. It's basically innate until you break up that concrete.
I don't know
Or
if
is-
that's entirely, so there's ground connected concrete, right, which has a water barrier, right? And so unless you encapsulate the concrete with some type of water barrier, there is the possibility for leachate. The other challenge is core drilling. Anytime you drill concrete, there's dust. It's unclear to me that this is as big a deal this is, when you look at the things that are actually.
These are a bigger deal.
Yeah,
The
when you look
fluorescent
at
bulbs are a bigger deal.
the availability of it and the pervasiveness of it, there's probably more focus that we should be doing. Because the reality is that mercury that ends up in fly ash is mercury that did not end up in the atmosphere, right? So if you take the source of most of the fly ash, which is coal-fired power plants, right? It's coal ash that's coming off the power production process. It's being scrubbed down. They're capturing that mercury. You could say that you're sequestering it in concrete. It gets I don't think
It's
enough.
better than the alternative,
Yeah.
but why are we burning coal?
Yeah, well, that's exactly the right, which is I think if you look at the real impetus behind the mercury and fly ash concern, it is being raised as a reason not to, because it's a revenue stream that is making coal-fired power plants more profitable or extending the profitable life of a coal-fired power plant. That might be the reason that this got raised as an issue to begin with. Because they want to take that revenue stream away from coal-fired power plants so that their economic outlook looks more bleak than it otherwise would. Right, so there's like 15 different,
But
molds.
where does
that you
fly
can
ash
wrap
go
around.
if it doesn't go into another material?
And into a detention pond, right? They just store it up and then it
Which
gets
is
all wet.
probably a riskier place for it.
Ask
then-
all those downstream from the Tennessee floods, right? That's exactly what happened.
So those are different kinds of issues to worry about.
I wanted to thank Michael and Layla for stepping up. Again, frog in my throat. Because unfortunately, Brett Little, he canceled on Wednesday, due to a family thing that jumped up, so I asked them if they could quickly put together this, so I thank them very much for this, because it was actually one of the ones that, I'm sure if they had more time, they would have had even more stuff in it, and it made it even more enlightening, but I can't wait to see the whole thing when you get all done with your paper and everything, because as an architect, I always want to try and do the least amount of harm, and sometimes if you don't know the knowledge, you can't. I know there's harm in all the materials I pick, and I want to try and pick stuff that's the least damaging, and the owner is still fine with it at the same time. Like, for example, I would love to do stoops outside exit doors that is just gravel, but that's not the standard out there. Everyone wants concrete stoops and they want it anchored in so that it doesn't frost upheave. And because it looks prettier than just gravel right there. Because gravel grows weeds and they have to maintain it. It's a whole process. So it's one of those things of trying to do the least amount of harm as possible.